Hi, Mike.
Hi.
Please tell us a few words about yourself and about the tool you want to show us.
Yeah, so our tool is called MLEM. Yeah, so let me share some slides for you. So MLEM is an open source tool, and it provides a flexible way to serve your models or package them for future deployment. And we codify your models, and we learn about them, all the metadata is needed to do this. And we define some standard interfaces and formats for data and for models. And it all can be customized for your needs. Basically, you can write your own plugins that you need for your pipeline or your workflow or whatever. And so how that came to be, I worked as a data engineer or MLOps engineer or architect for some ML projects. And my responsibilities often included writing some wrapping services for models to integrate them into existing like AT systems. And I wrote a bunch of this, and they were pretty similar because it is always like Flask or something like that. And you have your pickle model, and you write some endpoints like predict or something, and you serialize your like data frames for your model. So I thought to myself that like I'm lazy and this is like repetitive work, and I should write a framework to do this for me. So that was initial motivation. And then I thought that to do all of this, I need to collect metadata from model objects. And so because I need the exact requirements for this model, I need like to know what methods, what libraries do you use, arguments for those methods, because you need to serialize, like I said, the data that you send to those services. So that is why we came up with like two parts of our tool. One is codification. It is when you save your model with MLEM, you got like your regular binary that you will get if you like pickle or use some library tools to save this model. And also you got a separate file which has .mlem extension, and it has all the metadata that we collected about it. And in the demo part, I will show you how it looks. And after you saved your model, you can turn it into some package or into Docker image or into service or deploy it to cloud. And right now we're working on adding more like scenarios and platforms that you can use with MLEM. And also the very important part of our tool is that it built with GitOps approach. That means like it means that your Git repository where you have your code for training, for validation and stuff like that is like a central point of all. And you can use MLEM with DVC for, I think pretty much everyone is familiar, at least what DVC does. It stores your big binary objects, which models and datasets often are. It stores it in remote cloud storages like S3, but you still get the versioning power of Git. So you can store your artifacts with DVC and get model or data metadata from LEM. Also, we have this new tool called GTO, which allows you to tag your model versions, like tag your different commits of your artifacts, and then promote them to production or to staging, like in a model registry. And also we've got Studio, which is like a UI for all of those tools. And it looks very nice, and it will support MLEM soon. And you can use all those tools together with MLEM, and this will allow you to build like a full-scale model registry with artifact versions, with model versions, with comparisons, with deploying from them, with promoting between different environments with GTO, and of course with storing your binaries with DVC. So I think we can run the demo now, right? And after that, we will get to the question part. Yeah, okay. So for demo part, I prepared this notebook, but it's like to help me with the code, but we will run it from scratch. So I can show you that there is nothing except like the Git to the and environment basically, and this file. Okay, so we will start by training a simple model. It doesn't matter what model, but we will use classical iris dataset. Oh, it shows that it has something. Let me restart the kernel so we have like clean experience. Okay, so this part is actually has nothing to do with MLEM. You just need to. We need some model to show the power of MLEM. Yeah, so we trained like a simple random forest classifier, and it has like I think it has I don't know, it doesn't show how many trees it has, but like it's a very simple model.
Right, or 10? I think 10 is the default one, right?
Oh yeah, maybe we can see. Okay, doesn't matter. So the difference between your like standard machine learning workflow with the MLEM workflow is that you use MLEM to save the model instead of like pickling or using some other method. So yeah, let's import MLEM API save function and save the model. Here the model itself, here's the name for it, and some sample data. It is needed for MLEM to like know what type of data this model expects, and some descriptions. Actually, there are a lot more fields in save, but like
data is a data frame, right?
Yeah, and let me show you data.
Okay, so it looks at the features of this data frame, and then it knows that, let's say if you want to deploy this model, it knows what kind of features to expect, right?
Yeah, and we will see it shortly. Actually, this object can be also a NumPy array or some other type that MLEM supports, doesn't matter. And also, model object can be anything MLEM supports. For example, it can be Scalern model, it can be XGBoost model, it can be anything MLEM supports. We've got a list somewhere in the documentation. And also it can be just a Python function. So with this, you can pretty much turn anything into model, even if it is not supported yet. Okay, so yeah, we saved the model, and let's see what we've got. We've got the two files that I promised you, and we can see the contents of this ref.mlem, and it is a YAML file. It has all the metadata, and actually this is just this model object serialized because this model object is a pydantic model, if you know pydantic, and it can be serialized with the function. And let's just check out some of the fields. The description is just a string. Artifacts is the files that this model consists of. We got requirements automatically collected. We've got model type. It's a big field. It has all the methods of the model, And yeah, also the type of the model is scalar because we detected that it's scalar automatically. And as you can see, we never said that this is scalar model, and MLEM got it on its own. Yeah, also the file that we got, the ref binary, is just a pickle, and you can load it if you want to, like always. But MLEM got the MLEM API load function, which we will see later, that allows you to read those files basically. Yeah, and a couple of more things about fields. So we've seen artifacts, and this field can be used to just open those files more easily without like providing a path to them. And this is like the same pickle random forest classifier. We've got requirements, and they can be like used to install all the needed modules, for example, inside the Docker image. And the main one, model type, it's big, but yeah, let's see, as a dictionary. So it has the methods, it has and type, and actually it has the model, the actual model object that we saved as the model field. It has IO field, which is a simple pickle IO. It is not showed in the dictionary because it's default for this type. And basically this saves and loads model as a pickle file, right? And it has method signatures. And let me show you one of them. It's like a predict method. It has all the arguments. It has the return type. And we can see the columns that we used as the columns of the first argument, which is data, which is data frame. And this method returns numpy array of like, this means that it has one dimension. And type is int 64 because it's a classification problem. Yeah, so data can also be saved with MLEM, and the API is the same as for models. We also got some metadata from this data set, and basically is the same that we've seen here in signature. Yeah, we also can extract requirements for data, but instead of model type field, sorry, it has the data type, and reader. Reader is like a way to read the file that we saved, and it has like CSV format, and also the description of the data itself. And the data field again holds the actual data. And yeah, as we can read pickle file, model pickle file, we also can read the CSV file because it's just a regular CSV file. Yeah, also there is the notion of MLEM projects in MLEM, and MLEM project is just a directory with the .mlem directory inside it, like .dvc directory in DVC. And you work with projects pretty much the same, but you can also configure some options for MLEM projects, and you got some structure because all the objects are saved inside this .mlem folder. Let me clean the directory we're working in right now, and we start a MLEM project. As you can see, we just created this .mlem directory, and it has one config file which is empty. And let us change the file format for pandas, which is this option, pandas.default format, and resave all the objects. And now we have they were saved inside .mlem/data directory, but it's the same binary file and MLEM metadata file. But now, since we changed the default format to Parquet, we can read it as Parquet as if we need. MLEM also has API and CLI, and they're pretty much the same because CLI internally make calls to API, and you can seek help for CLI with -h as always. And we have some commands here. We will not go through them one by one because it will take too long, and it's all in documentation. And for example, MLEM-ls is like listing your objects in your project, and the API, as we saw, is in MLEM.api module, and it has pretty much the same set of commands, but list is ls because list is a reserved word in Python. Yeah, now we get to loading, and to load objects with MLEM, you just need to call MLEM API load method, and it has also a load meta variant, which loads not the exact object you saved, but the metadata object. So if you call this loader-f, you will get the same model that you saved. Also, we support loading from remote locations, for example, from S3 bucket, from GitHub, and this is very convenient. And you also can specify revision, which is like a commit or branch or tag to load. And here we use our get started repository, and it has pretty much the same model because it was trained using the same code. Yeah, and the location of this object is saved in this field. And again, we can see all the metadata for this object. And to load the actual value, you need to run load value and get value. And it will load the file from Git repository. And if it was in DVC cache, for example, it will load from there. So like you can use this load function for whatever, wherever your object is. And yeah, also you can use those methods that the initial model had, and you will get like the numpy array or whatever this model returns, right?
And if I want to do predict proba, for example, like model predict proba, or I need to get the original object.
No, oops. Yeah.
Because I guess this remote RF is a MLEM object, right? Not
yeah.
Or is it a scikit-learn?
Oh yeah.
This is a scikit-learn object. It's not a wrapper around it. Okay, got
so RF is a scikit-learn object, and the remote RF is a MLEM object.
Okay, but it also knows predict proba, right? Got it.
Yeah.
Nice.
That actually depends on the implementation of the wrapper of the model, and our Scalar wrapper, of course, knows about predict proba method, so that's why it works. But for example, it doesn't know about fit because we're not about training for now, and it will get you attribute error. Yeah, so actually now we get to the good stuff, because this part was about codification, and this part is about using those models. So the one thing you can do is just apply your model, and we have a CLI for that. API is not that exciting because you can just like apply it like this, right? But you also can apply from CLI, and you will get some JSON output with and you can also apply remote objects. Actually, everywhere you specify some MLEM object, you can specify remote object, basically. So this will also work slightly longer because it needs to load It's from GitHub, but still works. Yeah, but more exciting is to serve your model with some HTTP service or some other protocol. And MLEM can do this without any code from user side. So we have API command serve, and we have CLI counterpart also serve. You can see some help here. And we will serve our model with fast API, which is like the easiest option. And it has two configuration options. It's port and host. We will leave host as it is. And as port, we change port to 18. And as you can see, it started the server. We can go to this page, and we see like fast API open API documentation, and you can check out all the methods. You can actually try and call them. For example, yeah, so execute, and we've got 0 as prediction. We can change like to 10, and we've got 2. Also, you can see the curl that you need to run. So you can do like HTTP requests to your model. I will stop this because we need to go further. But also you can create specific client object from this server, and you will be able to call your methods like the model is local. I mean, like you will call client. Let me write it actually. Predict and data is a data frame, and it will return NumPy array. But like actually what happened was your data was serialized, sent to your model, got the response, and deserialized back to NumPy. Okay, next, building model packages, and for that we've got build command and build CLI. We use the API here. For now, we support 4 different types of build. It's 2 of them Docker. One is Docker directory, which means you just create a directory with Docker file and everything ready to be Docker build. And just Docker is the same, but you also build it into an image. And we've got 2 Python package builders. One is the same, it builds the directory with Python package, and one builds a wheel file. So for now, we will build the directory because building an image takes too long, and it has actually a lot of options. But the required 2 are server, which is like which type of server you need to use, and we still use fast API. And target is like a directory where you need this build. That was pretty fast. We've got some metadata about the build, and we can see that now we have this directory. It has Docker file, it has the model, it has requirements, and run. Requirements has all the requirements needed for the model itself and for server. Docker file has like some, like basically ready to be built Docker file, and run sh is just MLEM serve this model. We can actually go ahead and run Docker build in it, and it will succeed, but we will not check it because it will take too long. Also, let's try and build a wheel file. For that, you just change the implementation to VHL. Yeah, and this is ready, and we've got this wheel file. We can actually install it and import this module, and it will work, and it has predict like our model. I think it should have predict probe also. Yeah. Okay, and the last part, and it's still a bit of experimental, and for now we support only Heroku deployment, but we will add more platforms and more clouds soon. So this is like both packaging and serving, and also sending all of it to some cloud and running it there. So all of the above experience. For this to work, you need to declare your target environment, and we will use Heroku. Actually, you need to specify your API key for that, but I did Heroku login. So I don't need to specify API key. Yeah, here's the configuration option for it. And then you just use deploy API or CLI, and you run it for your model. And the staging is the name of environment that we created. Let's try and run. I don't know if it will run fast. Yeah, I think as we wait, it can take like a minute. I can answer your other questions, and we will finish the demo later.
So I was wondering, what does MLEM stand for? Does it mean anything?
Yeah, actually, it's a nod to a meme. It's like when your pets does this thing with your tongue, like this. And our logo reflects that.
There is a logo, like there's a cat. Yeah.
Yeah, but this should be a dog, but doesn't matter. And
It's a
if you
dog.
Google it,
Cat.
you will get some of those images.
I see.
Yeah.
I thought it's machine learning something.
Yeah. And after we decided for that name, we actually tried to came up with some abbreviations like machine learning engineers something, and we've got a bunch of those, and I think we will use all of them.
Okay. See. And it's most of iterative products, most of iterative tools are 3-letter abbreviations, and this one is a bit off because there are 4 letters, which is unusual.
Yeah.
Okay.
That's because they didn't have me when they named their previous tools.
Yeah. Okay.
Oh yeah, so we can get back to demo because it succeeded. Yeah, so we've got this meta file here, and we can load it just as model meta file, and we've got this Heroku URL. We can check it out. It has like the same Swagger UI. Yeah, and I promised that you can use client, and with this metadata, you can create the client from the state, and then you can call methods on this client and predict probe also. Yeah, so that's it for now, I guess.
That's pretty cool. Yeah, thanks for showing this. How many people work on this?
So right now we have 3 people working on this, like full time, and like some other advisors and people who like have the vision for iterative ecosystem. Actually, this will be a part of iterative ecosystem with DVC and GTO, as I explained on one of the slides. Yeah, but we're hiring now, and we will grow the team, and yeah.
Is DVC required to run MLEM?
No, it's not required. Actually, we have a tutorial for usage with DVC. It's not required, but if you use MLM with Git repo, then you either need to use DVC or store your binaries in Git, which is not advised.
Ideal. Yes,
Yeah.
I understand. Yeah. Cool. If somebody wants to contribute something to MLEM, what should they do? Like, how can they go about this?
Yeah, so of course we've got GitHub repository with the issues and with all the regular stuff. We have some issues marked as good first issues, then somebody can take on. And actually, I didn't show it here, but I said about customizable options for MLEM. And actually, every machine learning framework, every platform, and every, I don't know, packaging system is like a separate module. And anybody can implement their own. For example, if you need support for some rare machine learning library, you can implement it in and contribute, and those implementations live in mlem.contrib. I don't know if we can see. Yeah, so we've got like Docker implementation, Fast API, Heroku, NumPy, Pandas. Actually, there are more of those. Let me do it like this.
I think you have a
okay.
typo.
Oh yeah. Yeah, we have CutBoost, LegBM, XGBoost, Torch, and if you need some other implementation of some other library that we don't have yet, you can do it, and we will help you, of course, and show how it is done, and review your code if you need to. And you can either publish it as your own package, or you can merge it into this MLEM contrib package, basically. Yeah.
Can you show us how to give you a star?
Yeah, you should go to github.com/iterative/mlem, and yeah, basically give us a star.
Okay, thanks. So I think you briefly mentioned that you plan to hire more people. What are the things that these people will work on? Do you have any concrete plans for them? What's next for them?
Yeah, so after release, our plan is to fix all the bugs that we had, and also add some new bugs. So we have to fix something later. It's a joke, of course, but we will add them. The next big feature that we will work on is reworking this deployment API, because it works now, but it has its limitations, and we want to be able to like deploy from CI or something like that. And for now, it's tricky. It can be done, but it's tricky, and we want to make this very easy to use. And also, for now we have only one platform supported, and we will add all the clouds. We will work tightly with Seldon Core, because it's a pretty popular deployment system, and yeah, and of course Kubernetes and stuff like that. So this is our like Q3 plans, or yeah. And of course we will add more like more ML frameworks and like more implementations of everything.
Yeah, that's great. Great plans. Great tool. Do you have any advice for anyone who is watching this?
Yeah, if you are interested in MLEM, you can go to MLEM website and see documentation. It is a lot better than my tutorial, and we get started. We have a user guide and all the stuff, all the command references, and yeah, please try it and give your feedback. Of course we just released it and we've got a lot of bugs maybe, so you can actually help us make it better, and it's a good opportunity to have an impact on our tool.
Yeah. Thanks a lot. Thanks for doing the demo. Awesome tool. I'm really excited about this. When I saw the landing page that you created, like the simplicity of this, okay, it's really great. So, well,
Yeah,
all the
thanks.
best with the tool. Thanks a lot for doing this. I
Thank
guess
you.
that's all the demo. Thanks again for showing this, and yeah, see you soon.
Yeah, see you. Bye.